Yeah, good evening, everyone. Welcome to the week 5 live session. So today we will discuss week 5 programming solution, and also we will discuss the week 6 problem statement. So we will start from the first problem of week 5. Yes, Arnath, can you start?
Can I just join 5 minutes? I mean, there's a small problem with sound settings, I believe.
Okay, no problem.
Yeah. Can you hear me now? Is it fine? Hello?
Yes, Anna.
Yes, audible.
Yeah. So I believe, can you make again me the co-host so like when we start?
Sanath, you are not audible. Are you trying to talk it?
No, I believe I was audible.
Yeah, now you are audible.
Yeah. Can you make me the co-host again? Hello? Hello? Hello, can you hear me?
Hello,
Yeah.
there.
Yeah. Nice. Like, can you make me co-host? I mean, I believe I can't share my screen.
Actually, Sanath, I don't have the rights. Probably Atul might have the rights to make
Yeah,
you a
exactly.
co-host,
So
but
that's
I'm not sure whether he's going to hear you or not, or me for that matter.
wait a minute, and I will just like once again leave and come.
No, I don't think you have to leave.
Hello, is it? Can you hear me? Yeah, now let me share my screen. Sorry for the delay. Yeah, I believe like I can actually see. So is it visible, right? The screen is visible, right?
Yes.
Thank you. So let's go into the week 5 problem. That's what I believe we have to discuss today. So anyways, queuing systems. We define the number of people located in the queuing systems, either waiting in the line or in a service to be the state of the system at the time t. At t equal to 0, the state of the system is going to be equal to the number of people initially in the system. So you mean by so what it means is like we have a state, and the state means the initially it's going to be the number of people, the whole system or something. Say, people are standing in a queue for example barber shop, and the whole barber shop, the amount of people in the barber shop is said to be the state here. So we have two distinct classes denoted as A and B, which are said to be communicated with each other when there is a bidirectional link path between them. Suppose we have something like a person, sorry, just a minute. Okay, so I believe it's just there. Just a minute. I'll it's on my screen. Yeah, I believe the screen is visible now. So we have two states A, B. So we can say they communicate with each other if and only if we have like a path from A to B. That's what it's given in the question. So if we could move to the question again, yeah. So if all states are pairwise communicable, then they belong to same class. For example, we have say something like A, B, C, and D, and suppose E, F, G. So now we can say that as all states are pairwise communicable, like I can move from D to A by C, A to B, A to C, and I can move from anywhere, but I can't move from D to E. So this is known as maybe a class. That's what it's given in a question, class 1. And we can say this is like class 2. So this is what is given in the question. So what we have to find is, we have to find the number of such classes in the system. So I believe this resembles something, a very good terminology in graph known as components. So what we have to do is, we have graphs, we have a graph, and we have to find number of components in the graph. So this is the task we are given or assigned maybe. So maybe I'll just go down or something. Yeah. So now let's see the constraints one. So we see that it's 2 less than n less than 1000. So our number of vertices can be as large as 1000, and 1 less than m less than equal to n into n minus 1 by 2. So the total number of maximum edges possible in the graph is n into n minus 1 by 2, and it's 1. So we can have any number of edges possible. So what is our output is like we have to print the integer k. That is like, what is it? Then a total number of classes or components in the graph. So what can we do? So let's maybe dive into the solution maybe. Here I believe it's just that. Yeah. So yeah, this is what the solution is. So for counting the components of a graph, we can one perform DFS or BFS. It's basically your wish, but let's have a visit of a DFS based solution. So I believe everyone knows what is actually DFS, how DFS works. Suppose we have a graph 1, then 2, then 3, then 4, 5. So suppose we have something like this and we wanted to like go from, say, temp is, so the variable, and then visited is the visited vertex, and V is the starting vertex, and graph is the whole graph. The temp is the, maybe say, the list, basically, which the DFS order list in some sense. So we'll be going as depth as possible in this graph. So first we'll go, if we start from 1, then we'll go to 2. Our temp will look like 1, 2, then 4. Then actually we'll again come to 2. So we'll visit 5. Then again we'll go back to 2, then 1, then we'll come to 3. So this is how we'll visit the DFS. This will be our DFS path. And DFS path, for like understanding, we can go like 1, 2, and 3. Like we'll visit the level by level approach. Here we'll visit by depth level. So we'll go till the depth and then we'll come back and we'll try to find solutions, literally. So this is the difference between. So we'll now see how DFS actually can work with the solution. So we define the function called count components of a graph, where we initialize first visited array as false, or maybe in other languages you can go with zeros n times. Right? There are n zeros literally here visited. So now what we do is, for I in range of run of graph, so we actually iterate through every node of a graph. And suppose if it is not visited, we'll have temp, and and we'll find the components of that. So in some sense, what it does is exactly. So suppose our vertex 1 is not visited. So I have DFS, because DFS only works for the connected graphs. So if suppose it's not connected, it will return me again false, because of like the method DFS follows or BFS follows. What it does is, when I actually, if I want to check if the graph is connected, if I all the DFS vertices should be the components, right? I believe you can get it. Like, let me have another good example. Maybe say, suppose I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have some, say connections like this, right? So, like this, then like this. So these are my connections. Now suppose if I start with the vertex 1, my DFS will actually return me 1, 2, 3, 6, 5, 4. So this is what my DFS will return me. After this, so if I now this is one of the component, I have found the one component, and whenever I found my component, what I'll do is, like, I'll increment the component variable, or I actually here maybe append it to a list in some sense. In this solution, what I have done is I have appended to a list, and then I have returned the len of the list. So it's kind of, even keeping track of the components. So, or you just can increment the component. If suppose now these will be visited now. So visited of, suppose say 1 will be like, say 1, and visited of 2 will be, we'll say again 1. So it will go to the next unvisited vertex, where we have 7 here, right? 7 is next or unvisited vertex after we have finished this iteration. And now we can see that from 7, again my DFS will actually go into DFS, will give me an order of 7, 8, 9. Right. Yeah, 7, 8, and 9. So this is my DFS order. Again, my comp variable can actually increment to 2. Now again, unvisited vertex, it will go to suppose say 10. It can pick random any unvisited vertex, and then it will finish the DFS planning. And I update my visited dictionary too. So here I'll again increment the comp. So now comp will be 3. So now easily we could find that number of components in the graph is actually 3. So this is actually a very easy question where we have just asked to find the number of components in the graph. Believe like let's. So that's, I believe, like the whole question is all about it. Is there any doubt or like believe? Okay, there's a chat. Okay, anyway, sorry, I didn't see the dropping my query. Okay, there is one sentence. It is guaranteed that graphics connected. However, the example sample case 2 shows graph which is not connected. I mean, I didn't get your question exactly.
Sarnath, this is regarding week 6, problem 1.
Okay. Week 6 problem. Okay. I'll just check that. Yeah. Week 6, problem 1. Okay. So imagine you're training a robot with the help of reinforcement learning to understand the plan of scenario. Most of the RL model needs something called feedback. So give this feedback. We have to get the algorithmic solution that can help the DRL. The Chennai city can be represented as a connected graph with n nodes and m bidirectional images. Initially, the DRL model is at IIT Madras, is written over and you record it. Now the robot can wander from one place to another through this bidirectional. Whenever a new place is visited by the robot, which is not visited by the robot before, you have to record it. After all the places are visited, a final permutation. Okay, you are talking about this example, right?
So inside the input, one note is given in the last line.
Okay. Okay. So I believe they can be even. I think so. I made a mistake.
No, inside the input statement.
Yeah, that's what input.
Yeah, this one last.
No,
line.
the graph can have multiple. It's guaranteed the graph is connected. Okay, this is what, right? Okay, I believe that's a kind of increase. I'll just check this out and then maybe make the.
Yeah, so after checking the test case, we will update. Maybe we will remove this statement.
Yeah, I believe it. I mean, I thought to make it, but let me check the test cases once again and try to. I think so. It's not required to be the graph need not to be connected in some sense for this, but so if we can, maybe this line creates the ambiguity. Yeah, I understand. Okay, so is it fine? So can I explain? I mean, I believe like I'll explain once again the 6th. I think so. The test cases, they need not to be connected in some sense. So that's what I believe. Like, what is the point is like though it need not to be connected. I mean, the graphs actually need not to be connected. That's what is the point here. Like, that's the. No, what to say? I believe this note is like I made it for like no reason.
Yeah, okay, Sarnath, we will update this. We will remove this last statement. Just explain the problem.
Yeah, I'll explain the problem. So what it actually the problem states is we have a say robot which needs to collect something called so we have to give something called feedback for a reinforcement model learning problem. So what is the question is about is you are given a graph and you have to find the lexicographically smallest sequence of the nodes. Like if there are more than one components, you have to print, say the lexicographically smallest of like component which starts from the node 1. That's what it is. You should always start with the node 1 and you have to print the graph, which actually, suppose here we could see that we can go from 1 to 7, then 7 to 2, then to 7 again to 4. So again we can go from 4 to say 3. Then after 3 we can actually go to 9, but lexicographically smallest we can go from again 3 to 4, 4 to 5, as we have 1, 7, 2, 4, 3. Then we can have 5. Then we can come to 9 and then say 10. Right? This we need not to mention it because they are not connected, so we can leave the rest of the nodes as it is. We need not to actually add it in our solution. We'll have only this graph as our solution, which starts from the node 1. So suppose, is there any doubt in this question? If suppose anything is not understood, can you just ping me where things are wrong? So we just start from the node 1 and we have to get the lexicographically smallest sequence so that we find the nodes components. We find the order, how we can traverse like that. Exactly. So we can, I believe, is it? Yeah, exactly. Numbers are written alphabetical and ascending order, to be honest. Or like we cannot say, I mean, yeah, if number not ascending order exactly, but the traversal should be, I believe you can understand. It's just like we can't write 1, 2 here because it doesn't make sense. We can't go from 1 to 2 directly. We have to go from 1 to 7, then 7 to 2. Then we can go from 2 to 7, 7 to 4, 4 to 10. And then again 4 to 3. Then now as we can visit 5 before 9. So we have to visit 5. Not like that, not the name of the number. No, it's not like that actually. It is 1, 2, 3, but what it actually does is like as 5 can be visited before 9, right? So we have to visit 5 first and then we have to visit 9. Believe. Can understand. Just the value wise numerically, yes. It's not of alphabets. We don't care about alphabets in the starting. That's not the case here. We have to just find the value numerically. Is it so understandable? Like, did you get the question?
So that means we can say that in the increasing order.
Yeah, increasing order. Yeah.
In the numerical value.
Yeah.
If we have only 1 or 11, so that means 11 should come after 1.
Yeah, exactly. Yeah, that's the, I believe that is even more clear.
Okay.
So suppose no more questions, then
any question in this week 6 statement or any week 5 problem number 1? Okay.
Suppose then let's continue with the topic. Thank you.
Yes. Yeah, Pushpin.
So I'll share my screen. Okay, so is everyone able to see my screen?
Yeah, actually, yeah.
Yes. Thanks. So the week 5 statement is pretty straightforward. You're given a binary tree and you have to pin the sum of all root to leaf paths. What it essentially means that you have to find a path which starts from the root and ends at the leaf node, then you have to print sum of all these paths. So moving forward with this problem statement is this. So we start at 1. I hope the problem statement was clear for everyone. It was pretty straightforward. There were no hidden agendas in this problem statement. So you start with the node, first node. You get the value of the node, which is 1. Ignore the 5 and the 9. They just happen to be there. So you get the value 1 when you start from the root node. Then you move to the second node where you increment, multiply the earlier value that you got from the parent node by 10 and add the current value of the node to the result. Now from 2 you go to the next node on the left, meaning you can choose between left and right. It's arbitrary, but at the end of the problem statement is that you have to traverse from root to leaf. So once you are at that leaf node, you produce a value which is your final root to leaf path value. Now once you have generated this value, you have to add it to the remaining root to leaf path. So you from 3 you go back to your parent, then you go to the right, which gives you another result of 1 2 multiplied by 10 plus 4. So you can't use this because it doesn't fall in this path itself. So you move to your now at 4 you don't have a left node, so the only choice that you have is to move to the right. You do that, you multiply the value of that was supplied by the parent with 10, add the current value of the node. At 6 you have reached your leaf node, which gives you the second value of this output, which is 1 2 4 6. Then you go back to your since we are at the leaf node, you go back to 4, you go back to your second node, you go back to 1. Now the entire left subtree has been visited, so you move to the right subtree. Now the next is that you multiply again the value that was supplied to you by the root node, that is 1, multiply it with 10, you add the node value, which is 6, you get a 16. Now you're still not at the root leaf node, so you move to the left subtree, you reach 5, and because you don't have a left subtree or a right subtree from 5, you produce another value, which is 165, and the output of the problem statement would requires you to add all these root to leaf path sum, which is 1534 that you should be getting. Now share the problem statement. So this is the solution, example solution that we have. It's a recursive solution. This is just a specification of how you are going to store the binary tree itself with a value and left and right node. This is just for the input itself. Now this is the essence of the problem statement, which is just a recursive solution. You start from the root node, you add now this value is added to the current value would be 0, so you multiply with the root value and multiply with the value that was provided, which was 0 in this case, and you add the value. This next value is supplied to the next recursive call, and if you have the left and right node, you get the sum from the left, you get the sum from the right, you add it up and you return the result. If you have a root to leaf left, both of them are none, then you just return adding the value of the current node and you return the result. And if either of them are none, meaning left or not, left is not, it doesn't have a left subtree. It does have actually a left subtree, you go to the left. And if you have the right subtree, meaning obviously it's a else condition, that means it has a right subtree because we have checked for all these conditions. You go to the right subtree and get the result. So that is the entire solution, how you're going to approach from a recursive point of view. Any questions on the problem statement or the solution of week 5?
Yeah, hi Krishnan.
Yes.
Yeah, in the problem statement, it is mentioned that the value of node lies between 1 to 9.
Yeah. You mean to say that the problem statement, because it stated that it should be between 0 to 9, meaning 9 including but 0 excluding, right?
Yeah.
So, but in the problems, in the private test cases, there were some values which was 0.
Yeah.
Right. So yeah, we had a talk, some of those test cases, private test cases, I don't know what exactly is going to happen, but from the solution point of view, even if you have that 0 value, it won't give you a different result. Because if you have a 0 at any point of time, meaning if you have at the root node itself, you multiply, you're essentially multiplying 0 to, it's just like what we have here. We are multiplying 0, right, to 10 and we're adding it. So even if we look at the from the solution point of view, yes, meaning from the assignment point of view, yes, that was a mistake that we didn't account for the value 0. But from the solution point of view, it should the presence of 0 wouldn't have any impact on the solution approach of the solution itself.
No, actually, it will have some impact because
Like?
I am applying reverse operation. So it's
Reverse?
0. Yeah, like in my approach, like if you go to your PPT, like it is 1,
Yes.
2, 3.
Sure.
Yes,
Just give me a second.
Shrey, okay, so we are looking into this. We are just figuring out the test case in which we are taking this 0 value, and we will remove these test case, and those test cases are not containing the 0 value. We will consider for that only the evaluation.
Yeah,
Okay,
they
so
are
we
4
are
test
just
cases. Yeah.
you are saying 4 test case, but I think more than 4 test case have 0 value. I'll check these things, and based on that we will do.
Yeah, there are total 7 test cases and 4 test cases 0 value. So actually, I'm applying reverse operation. So as a result, my 0 answer is getting some incorrect answer.
Reverse operation as in like
suppose here we have 1, 2, 3.
Yes.
Suppose we have 0 at the last 1 to 0. 3 is not there. Suppose 0 is there.
Okay.
So now when we visit 1, then we have 1.
Yes.
Now in the second case, we got 2.
Get 2. Yes.
So what I am doing is that I'm putting 2 in the second position because I am planning to reverse the sequence. So I will get 2, 1.
Yes, sir.
So are you using post order or like instead of pre order?
No, because I am planning to reverse the number in my final step. In the pattern, we can use reverse number. Reverse string is there.
But we don't have to the problem statement. But when you are forming that number itself, it has to go from root to leaf, right? Not
yeah. Let me finish. So first we got 1. The second we got 2. So I will store it as 2, 1. Then we got 0. So then I will store it as a 0 to 1. But as 0 is coming in the variable, 0 is coming in the first position, so the variable is getting ignored. So when I reverse,
so let's just engage with that thought process. So what you're saying is that I have this. Okay, so you have this. Now what you're doing is you're visiting first node, right? Then you're visiting second node.
When I visit second node, I will store it has a 21.
Okay, store it as 21.
Because I am planning to reverse when I reach the last node, I am planning to reverse my variable.
Okay.
So then when I visit 0, then it will be 0 to 1. The number is 0 to 1. So the 0 is getting removed when I do the reverse operation because it is variable. and it is not mentioned. So even I did not test with the 0 because it is clearly mentioned. We don't need to check with 0 constants in the problem statement.
So how many test cases you are passed?
3 is passing for me, but 4 which contains 0, it is getting wrong answer.
3 as in like, let me just open that.
But I feel
solution.
that this 0 is exist in more than 4. So some
No,
test case is passing, which is also have 0.
No,
So
some test cases won't contain 0. Like,
so you said you're passing 3. How many test cases are you passing?
I think three test cases I am getting.
If you see the first, test case have 0, but only the second test case I
Yes.
think doesn't have 0.
Yeah, second is don't have 0,
And other also have 0.
And
You can see third is also.
So if 0 comes in between, then there won't be any problem. But if 0 comes in the leaf node, last position, then it will give a wrong answer.
Okay.
So my case, like in test case 5, in test 5 also 0 is there, but it is passed because it is in 0 is coming between.
Okay, so you are saying that you are producing a result which is leaf to root actually, but you are reversing it back at the time of actually outputting.
Yeah,
at the output generating that result.
Yeah, correct. So test case 5 also contains 0, but it is passed because the 0 is coming between, not in the leaf node. 6 also contains 0, but it is passed. So I think some 2 or 3 test cases is getting failed in my test.
So you use, okay. How many test cases did you pass? Do you have that number?
Yeah, it is.
Can you tell me which test cases are passing?
It is showing 3 out of 7 test cases passed in my cases.
3 out of 7.
Yeah. So test case 2 is passed, test case 5 is passed, and test case 6 is passed.
Sorry, test case 2 is passed.
Yeah, test case 2 is passed, and test case 5 is passed, and test case 6 is passed.
5 is passed and 6 is passed.
Yeah.
Okay. I don't see this test case in this.
Yeah, 0 is not in public test case. It is passed. All the public test case is passed.
No. I'm asking. Anyways, we'll discuss it, and we'll take some corrective actions depending on that. So, given the fact that these cases would also be ignored, I think. Only one. Anyways, we'll have that discussion, and I'll get back to you on that.
Okay, yeah.
Okay.
Thank you.
So, let me share the week 6. So the problem statement is Mr. Sivan has a large farm which is divided into small areas, and each area is watered through channels. Help Mr. Sivan to find out the minimum time it would take for water to reach each area in the farm from the given source of water, if it is indeed possible. Each area is denoted via a node labeled from 0 to n-1, and each directed edge represents the direction in which the water will flow from the source area via channel into the destination area. The weight of each edge represents the time it would take to reach from the source area to the destination area in seconds. Now, this is the example figure, and if you look notice this there's a directed edge from node 1 to 0, directed edge from 1 to 2, and a directed edge from 2 to 3. Now the constraints are that the value has to be between 0 and value of the node would be 0 and n. It's just a representation. It shouldn't have any bearing. The number of nodes would be between 1 and 1000, excluding 1. The weight of each edge has a value between 0 and 10 raised to 9. Now, explaining the input itself, what you're given is the number of areas, and meaning number of small farms that are considered. Here there are 4 nodes, meaning because we are representing it as a graph, the source would be 1, and the edges would be in the next column. So this is like, so 0th index would has actually 0 outgoing edges. So if you look at this, there are no outgoing edges. Now, if from first node, there are 2 edges, one from 0 to 1, meaning this is the weight. Actually, this is the destination vertex. So from 1 to 0, you have a edge weight 1. From 1 to 2, you have an edge weight 1. In the second node has only 1 edge, which goes from 2 to 3, and the edge weight is 1. For the third node, there are no outgoing edges. So this is how you're representing. So you get first input of that each line, and each number of, meaning n vertices, you have the number of edges. So in this case, you have, for node 1, you have 2 outgoing edges. So 1 to 0 and 1 to 2. The format is that you specify the destination space, your edge weight, and any node that doesn't have an outgoing edge would be marked as, would be having 0 as the input line for ith node for which there is no outgoing edges. Any questions on the this, meaning week 6 problem? Any confusions? Take that. See if there's anything in the chat. No. Okay. Thanks, Akash, for confirmation. Any questions from anyone else? I'll take silence as no. I'll stop sharing my screen. I think I'm done.
Okay, Pushpendra. Yeah. So Shrey, we will check this programming assignment which you have mentioned, and we will take the action accordingly. Okay, so
Yeah.
don't worry about this.
Yeah. And actually, and one more thing, that is, if we apply, like I'm shifting the position of the variable. So if I apply 0 with any numbers, it will be 0. So that will also won't shift my number. So that might be also be the reason.
Even if you're solving that problem statement, the idea behind that is, meaning the way you're approaching is not, I'm not sure whether I would say it correct or not, because what you're it should come from the traversal itself. Now when you're doing from root to leaf path, you are generating the values at that moment itself. So the problem shouldn't arise, meaning that's said, meaning, but here I'm glad I heard the way you are approaching this solution. So whenever you are going from root to leaf path, try to ensure that you're moving from root to leaf path and generating values instead of leaf to root path. Meaning there will be some situations where you have to actually traverse. Meaning, if I were to say that generate sum from leaf to root, in that case, it would make sense. So try to get the essence of that screen visible. No, Dhruv, I have actually stopped sharing my screen. Do you have any questions? You can unmute yourself and probably ask your question right now. But let me finish first. So should any confusion, meaning like I understand where you're coming from, why you're getting this, and I didn't anticipate that this would be an issue. But yeah, when someone is when the problem statement asks from root leaf, meaning you have to traverse the depth first search, try to generate the results up front instead of delegating at the end of your meaning you do an operation. This would also be an operation, right? Meaning you have to reverse the entire string what you have generated again to generate that sum, right? You have to convert that into an integer and then do the sum. Am I correct? So that is you're adding a cost to that entire operation.
Yeah, that is correct. But in the problem statement, it is clearly mentioned that the zero node cannot have zero value. So even I can
that's fine. That's fine. It's not about. It's not about the. I'm not arguing with the idea that the statement is correct. That is not the intent here. What I'm simply telling you is that when you have a traversal, try to generate results at the moment you are at the node itself, instead of delegating it to the end of that process itself. So you're generating the root to leaf path, but you're populating values from leaf to root, and then actually you're doing a reversal of that value that you have generated. So 0 to 1, you're generating it, you're generating 0 to 1, but you are again actually reversing it back to 1 2. So that is an unnecessary operation that you're performing. Actually, it has nothing to do with the problem statement, meaning like the correctness of the constraints. That is a separate topic, right? But what
the reverse operation is giving some extra, taking some extra cost that you are mentioning. Yeah, correct. Yeah, it is. I agree. Yeah, that reverse operation is taking extra cost. That I agree. Yeah.
Yeah. So that is the intent that I'm trying to. That was the intent behind this question. But nevertheless, that is a reasonable statement. We'll take care of it.
Yeah.
We'll have yes. Do you want to take that questions from?
So this actually we have this video content only till week 10. After that, you will get only assignments based on the greedy, dynamic programming approach. Okay, so content is available till week 10 on. So week 10 is dynamic programming, and the assignment will remain on the dynamic programming in week 11 and week 12.
Do we have any plan to discuss practice coding problem, or that we have to do
practice coding problem solution is already available in the previous live session, which is available on the portal. You have to just visit the previous live session and you can see the solution.
You mean the live session video?
Yes, live session video on the portal, which is available for the previous terms. So that problem is already discussed in the live sessions.
Okay, maybe I was. Yeah, okay.
Okay, regarding this problem, we are looking the correct solution, what we can do. Okay, so don't worry for this.
Okay, yeah, thank you.
Okay.
So practice all उसके practice problems के भी वो marks है क्या? Practice programming assignments?
No, उसके नहीं है marks. वो practice के लिए है, उनके solution practice programming question के solution आप previous term के live sessions में आपको solution मिल जाएगा. ठीक है?
Yes sir, thank you.
Marks से केवल graded theory, this quiz and programming set only. Okay. Okay. Anything else? Any query?
There's someone asked a doubt in the chat.
Okay, what doubt? Doubt in problem solving. Reduce problem statement meaning fast with example and start coding my approach from input recursive function. Oh, I think you also mentioned your question in the Google form. Let's see. Most while coding it comes where my approach is missing edge cases of error. Yeah, it actually happens with everyone if you just started this competitive programming. So initially you will get some distraction or this type of error mistakes in your solution code. You maybe will not figure out the corner case. So, but after some time, maybe 6 months or 1 year of the practice of this on this competitive problem, so you will get a proper idea where you need to think when you're writing the problem. Okay.
So I'll like to add on that, Akash, query.
Yeah, please.
How I approach any problem is the first, meaning the most difficult issue with any competitive programming that you're doing is getting the problem statement right. Meaning you need to first read the problem statement correct. Meaning you need to get the idea what the problem statement. Sometimes when we are approaching the problem, we start coding, and we realize that the problem statement itself is wrong. So first, try to get the chalk out like big ideas from a problem statement, that what they are actually seeking. The edge cases would obviously it's like for the consideration of edge cases, it's like how much you have experience with the problem solving itself. There are some problems where you will be able to have the edge cases right up when you're thinking about the problem, but it's most competitive programming is about feed and then burp. So you have to feed yourself with that information. What could be the only way you can actually account for edge cases is if you fail a lot many times. Then you have to fail first to have that so sort of information stored in your brain. So don't worry, but make sure that when you're approaching any problem in any of the competitive platform, instead of actually start coding, try to first use a pen and paper. Try to draw the problem statement itself. Write the code within or using a pen and paper itself. Don't start coding, because the essence of competitive programming is not just problem solving. It has to be whether you are getting the your solution of the using some programming language correctly or not, because that is also one of the some of the issues that might creep in. Meaning, like, because we have so many well advanced IDEs, we don't have to worry about those. But from a interview point of view, you need to know when you're writing or using a pen and paper, you have that clarity of thought that this is the function that is going to work for me or not. So try to use pen and paper at the start of the problem statement. Don't explicitly rely on the coding IDs at the start of the problem statement. Understand the problem statement, recognize the constraints. Start it easy, using small for loops or something of very easy constraints, so that you can at least solve the basic cases. Then try to figure out the approach, how you can maximize that, minimize that time TLE. Does it make sense, Akash? You can use email unmute button. Okay, good to hear. So there are actually just there are many actually platforms there. You have HackerEarth, HackerRank, LeetCode, you have CodeChef. All these are like coding platforms, and it has even Google coding competition questions. Meaning, obviously, that is very much specific to your Google coding competition, but the problem solving can be done on any of the platforms, and there are n number of platforms available for your practice. Any more questions?
Yeah, Dhruv
Anyone?
is mentioned that spelling of hierarchy is incorrect in mode 7 lecture 41. So it is in video, inside the video or any place. So okay. Yeah, it may be happen, but it is in video, so it is difficult to remove. Okay.
Title.
Yes. Video title. Okay, okay. Okay, if it is video title, so we will correct this. Okay. Okay. Anything else?
Thanks for the compliment. I think Atul will be very happy to hear that.
What it? Yes. Okay. Thanks, everyone.
Thank you. Thank you all.
Thank you.
Bye.
Yeah.